Prepare to embark on a thrilling exploration as we unveil the untold secrets behind the failures that have plagued rockets throughout history. Join us on a captivating journey through the captivating video, The Real Reason Rockets Fail, where we uncover the enigmatic forces that conspire against these mighty machines, shattering dreams and challenging the limits of human ingenuity. Rockets need thousands of things to go right to reach space, but just one issue can bring things back down to Earth with a bang. This year has seen a record number of launch attempts, so it is unsurprising that sometimes things went wrong. Design flaws. Design flaws in rockets can lead to catastrophic failures during launch or in flight. These flaws can encompass various aspects of the rocket's design, including structural integrity, aerodynamics, and propulsion systems. For example, a weakness in the rocket's structure may cause it to buckle or break under the extreme forces experienced during launch. Flaws in the aerodynamic design can result in instability or excessive drag, causing the rocket to veer off course or fail to achieve the desired trajectory. Inadequate or faulty propulsion systems can lead to issues such as insufficient thrust, unstable combustion, or failures in fuel delivery, all of which can jeopardize the mission's success. Design flaws can arise from a lack of thorough testing and evaluation, inadequate consideration of environmental conditions, or errors in engineering calculations. Addressing design flaws requires a comprehensive understanding of the complex interactions between different components and systems, as well as the ability to iterate and improve designs based on lessons learned from previous failures. Manufacturing defects. Manufacturing defects can be a significant factor contributing to rocket failures. Rockets are incredibly complex machines with thousands of components, and any error during the manufacturing process can have severe consequences. These defects can range from structural flaws to faulty materials or improper assembly. For example, a small crack or weakness in a critical component, such as a fuel tank or engine nozzle, can lead to catastrophic failure during launch or in flight. Inadequate quality control measures or oversight during manufacturing can allow these defects to go undetected, making it even more challenging to identify and rectify potential issues. Manufacturing defects can compromise the structural integrity, reliability, and performance of the rocket, significantly increasing the risk of failure. Material failures. Material failures can be a significant cause of rocket failures. Rockets are subjected to extreme conditions during launch, including high temperatures, intense vibrations, and pressures. If the materials used in the construction of the rocket are not able to withstand these conditions, they can fail, leading to catastrophic consequences. For example, if structural components, such as the rocket body or engine casing, are made from weak or brittle materials, they may fracture or deform under the stresses of launch, compromising the overall integrity of the rocket. Similarly, if the heat shield materials cannot withstand the intense heat generated during re-entry, they can degrade or fail, risking the safety of the payload and crew. Engine failures. Engine failures are one of the significant causes of rocket failures. Rockets rely on their engines to provide the necessary thrust for liftoff and propel them into space. Any malfunction or failure in the engine can have severe consequences. Issues with fuel combustion, such as improper mixing or ignition, can result in reduced thrust or even complete loss of engine power. Malfunctions in engine components, such as valves, turbopumps, or fuel lines, can lead to disruptions in the flow of propellant or loss of pressure, compromising the engine's performance. Engine failures can also result from inadequate cooling systems, causing components to overheat and degrade. Propellant issues. Propellant issues can be a significant factor contributing to rocket failures. Rockets rely on a precise mixture of propellants to generate the necessary thrust for launch and maneuvering in space. Any miscalculation or deviation from the intended propellant mixture can have detrimental effects on the rocket's performance. If the propellant mixture is not properly balanced, it can result in inefficient combustion, leading to reduced thrust and compromised acceleration. Moreover, propellants can degrade over time or become contaminated, which can further impact their performance and stability. Such degradation or contamination can lead to inconsistent fuel burn rates, uneven combustion, or even explosions. Biggest rocket failures. Despite the number of historic launches that did go well this year, there were, of course, those that either never made it to space or failed to deploy their payloads once they got there. Here are 5 such launches that didn't go well. 1. Astra rocket CVFFER's K-Tastrofix FFAILURE in 1 ST Ephilourida lying in Shach. Astra, founded in 2016, is looking to secure itself a place in the launch market and look to build on a successful flight of its Rocket 3 series in November 2021. However, its February 10 launch ended in a spin. The two-stage LV-0008 lifted off from Florida's Cape Canaveral Space Force Station today and performed well initially, soaring high into the Florida skies, but an issue occurred around 3 minutes into the flight. 2. Third FALURE in a row for ISPACE's HIPERBOLA-1 rocket. Back in July 2019, iSpace became the first Chinese private company to launch a rocket into orbit using its four-stage Hyperbola-1 solid rocket. Things have not gone so well since then, with 2 failures last year being followed up by a third consecutive launch failure. The fourth Hyperbola-1 lifted off from Jiuquan Satellite Launch Center in the Gobi Desert on May 13. All seemed well early on according to amateur footage, but silence followed in place of a confirmation of launch success. 3. Astra rocket CFFER's second failure, 2 NASA satellites lost. Astra suffered a second failure in 2022 on June 12, which cost the first 2 NASA Tropics CubeSats to steady hurricanes. We had a nominal first stage flight. However, the upper stage engine did shut down early, and we did not deliver our payloads to orbit. Astra's Amanda Dirk-Fry, senior manager for the first stage and engine production, said during live launch commentary. This was the second failure of Astra's Rocket 3.3, which prompted the firm in August to cancel the launcher and transition to a next-generation launch system called Rocket 4. 4. India's NEDU small satellite launch vehicle fails first flight test. India launched a new rocket named the Small Satellite Launch Vehicle, SSLV, from the Satish Dhawan Space Center on India's southeastern coast on August 6, with the inaugural flight going well for the early stages, before hitting a snag on the fourth and final stage. A sensor issue meant the upper stage failed to deliver its 2 satellite payloads into their intended orbit, meaning they could not be used. 5. Nimu SHPRD SISUFFER's NOMALI during launch. Blue Origin's new Shepard reusable suborbital rocket has gained attention with its tourist flights from Launch Site 1 in West Texas, sending up to 6 people at a time above the Kármán line, the unofficial boundary between Earth's atmosphere and the beginning of space at 62 miles, 100 kilometers, above mean sea level. As we come to the end of this gripping journey through the captivating video on the real reasons rockets fail, we are reminded of the awe-inspiring complexity and inherent risks involved in space exploration. The failures of rockets serve as poignant reminders of the tremendous challenges that scientists, engineers, and astronauts face as they push the boundaries of human knowledge and venture into the unknown. Yet these failures are not defeats, but rather stepping stones towards progress. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.